Alright, so the second type of problems that we'll be getting is that you're given a slope field and you have to match or select which differential equation actually fits the slope field. Okay, so first thing I just want to highlight is maybe it'd be easier for us to simplify these. Okay, so this one I could factor out an x, and then I have y minus 1. Okay, and this one I can still factor out an x, and I'm going to have y plus 1. Okay, and all the other ones are pretty much simplified as much as you can get it. Okay, now the first thing I want you to notice is that we have all horizontal lines at y equals, let's see here, 3 is the top, so 1, 2, 3, 4, 5, 6, so that's y equals 1. Okay, now what that tells you is that your dy dx is actually going to have a factor of y minus 1. Okay, so looking at that, there's only, well, we can eliminate a couple of them off the bat because of that. We can get rid of this one, okay, and we can get rid of that one. Now all the other ones have those values. Okay, now the second clue I want you to notice is that we have all horizontal lines along the y-axis. Okay, so what that's telling us is that we're going to have a factor of x equals 0. So let me just add that up here. Okay, so again, that's not really helping us out too much because it's kind of matching there and there. Oh, sorry, I misread that. We can also cross out e. Okay, so now that we've actually looked, those are like the two obvious ones. If we have any horizontal or vertical lines, those are going to help us out a lot. Those tell us the factors essentially. Okay, so now that we've taken care of that, we have to decide between A and D. Okay, this is where it might be good to just actually plug in a point. Okay, so if I decide to plug in 3, 3, okay, notice up here that the slope is positive. Okay, so if I actually plug that into my differential equation, okay, either one of these, I'm going to get 2 times 9 here, so that's 18. Okay, and then up here I'll get 3 times 2, so 6. Alright, now again, that doesn't really help us out very much because they're both positive and so is this thing. Right? So maybe we could look down below here. If I look at 3, negative 3, that might make a difference. Okay, so I'll do this one in green. Okay, if I plug in 3, negative 3, I'm going to get 3 times negative 3 minus 1, so that's negative 12. Okay, over here, I'll do negative 3 minus 1 times 3 squared. Okay, so again, that one seems a little large, so that's negative 4 times 9 is negative 36. Okay. And all you're going to do is end up like testing maybe one point in each quadrant until you can, figure out which one it's going to be. Okay, now just based off of the size of the slopes that we've gotten so far, I'm probably going to go with this one. Okay, but notice that, the main difference here is there's an x squared factor. Okay, so really where we're going to see a difference is over here in these quadrants. Okay, so if I picked negative 3, 3, and then I plugged it into both of them, let's use blue. Okay, then if I plug in negative 3, 3 here, that's negative 3 minus, that is 3 minus 1, and then negative 3 squared. So 2, 9, that's 18. Okay, now I don't have a positive slope here. I have a negative slope, so that just essentially eliminated D for us. Alright, so our choice is still going to be A. Okay, we have the same basic idea here. Okay, look for verticals and horizontals, and that's going to tell you your factors. Okay, so I have horizontal here at y equals 0, so I'm just going to have a y factor, and I have horizontal here at x equals -1. Okay, so that's going to be x plus 1. Alright, again, simplify these if you can, so y, x minus 1, y, x plus 1, x, y plus 1, and that one we can't really simplify. Okay, now I can just eliminate the ones that don't have the right factors right off the bat. So that's gone, okay, that is gone. Okay, and this one, even though it has the x plus 1 factor, it doesn't have the y there, so that's gone. So answer is C. That's a lot easier than the last one. Okay, and finally, the last type of problem with slope fields you might actually see is one like this, where again, you're given the slope field and you're given a starting point, and they're asking which one of these could actually be the function whose slope field we have up here. Okay, so in this case, I mean, start with your starting point. Okay, and like we did before when we were graphing the solutions, let's just graph the solution. Let's find the graph of y. Okay, and it'll smooth out up here, and then it's going down and flattening out again. Okay, so this definitely isn't going to work. That's not going to work. This would be a half circle, right? So the graphs of these look like this, this, and this is a half circle, so it's just going to look like that. Okay, but this one, okay, if you remember from pre-calc, it's going to be 1 at 0, and as we go out towards the ends, it's going to be getting close to 0. It's going to be flattening out. Okay, now cosine's also kind of similar. Okay, cosine looks like that, right? I mean, it's a bad picture, but it's generally okay. Alright, that's going to be pi over 2. Okay, that's going to be 3 pi over 2. That's going to be pi. Okay, remember pi is about 3. Okay, so even though this looks the same right here, remember this is flattening out as the sides go across here. Okay, cosine doesn't flatten out, it goes farther down, and then it starts to flatten out under the x-axis over here. Okay, so we can eliminate cosine as well, and we're just going to be left with E. Alright, well that's about it that you're going to see with slope fields. I'll see you later.